Hi everyone. Sorry we got cut off at the end of class. This is something maybe that, who knows, continuing education, if we get cut off at the end of the period, teacher can make a quick video um, during those 4-minute periods in between or if you have off. So again, we mentioned that, choose a different color here. We calculated the force of friction. We calculated the x component of gravity. One's going up the mountain or hill, one is going down. And the question that we have is, are we going to accelerate? So this is like an advanced problem. If there was like an honors summa, this would be a great question because it really shows like all the force diagram drawing, the components, the trig, and then now a new Newton's second law, and then something about friction. So at a quick glance, we say more force is going up the hill. So we think, oh, we're going to accelerate up the hill. But remember I said he's just standing there. And the piece of information that I did not give in the beginning, because it's random, like I didn't know what you guys were going to say. So I didn't know whether this force of friction was going to be static or kinetic because of the angles and the mass you gave me. I didn't know. So I didn't tell you. So if he's going to move, like slide down the hill, it would be kinetic because he's sliding, he's moving. If it's static though, remember static friction is a maximum force. So friction, you're not just going to stand on a hill or an incline and friction is going to make you go up unless you start to walk, and then we call that traction. So we're not getting, involved there. We're just standing there. So since the friction is greater than the force going down the hill, this is going to be a force due to static friction. So that our mu would be static, and then all of that information would be static. So we were looking here to see if we're going to move. And we find out that the static can withstand up to 629 newtons. The way the angle is and the weight of the person is only 438, so he would be safe to stand on this hill without sliding. So the acceleration would be 0. If for some reason the mu's were different and the angle was different, and that component of gravity down the hill is greater than that static friction, then we would know it was kinetic. So if that was the case, we would continue to move on and say sum of the forces equals mass times acceleration, and the forces we would be looking at would be kinetic, where one of these would need to be negative. I think I mentioned that gravity in the x direction is going to be negative. Let me start my office hours meeting real quick. And then we can continue to go in and plug in those values that we had and come up with some kind of acceleration. So while we're on so if you could do that, or at least understand that, I think you're more than good for the Summa. Some other things to review, maybe take a look at your Newton's Laws packet, the force diagrams and net force packets, look at the reviews, maybe try them over again, look at your quizzes on Schoology, look at your circular motion packet, and the review for that. I think you guys are going to be pretty well off, keeping in mind it's same academic and honors. I did want to address one thing. We ran out of time. A lot of times our summas, the open-ended, are directly related to labs that we did. Now, we didn't have the opportunity to do the lab individually because you couldn't manipulate equipment in class or virtually. So we talked about friction a little bit. So the only way to measure friction is experimentally because every surface is different, right? You can't say the mu value of wood and plastic is a certain number because every piece of plastic microscopically is different and every piece of wood is different. There's published values for averages, but if you really want to truly know, you have to experiment it. And to experiment that, you're going to have to drag that object along a surface and have some kind of force sensor. So if we had a force sensor that measured force of friction with respect to time, and we're dragging it, at a constant speed, so it's at rest, and we start to slowly pull, that friction is going to start to increase. And then again, it's not moving at this point, but then it's going to level out. Because remember, we said static friction is when all those nooks and crannies of those surfaces are interlocked. And once they become unlocked, it's a little bit easier to get them slide past each other. So this would be whatever number this would be, right, on our friction axis. This would be our static friction. So force, friction, static, because that's a maximum value. So the maximum value to cause the object to move. So if it's less than that force or equal to it, it's not going to move. If we apply more than that force of static friction, then it will start to move. Then it leveled out, and this is where we looked at our force of kinetic friction, whatever this value was on our force axis. So your static is always going to be greater. Kinetic is when things are going to be sliding, those surfaces are sliding with respect to each other. And static is when they maxed out to not move. So hopefully that was good enough. If you have questions, feel free to come in during office hours this morning or afternoon. Just if it's going to be in the afternoon, send me some kind of message so I can send you the link to that Teams meeting. And as well, if you have questions about the SUMA, I'll open up, the beginning of Monday's class before we do the SUMA to any kind of questioning that you guys have. And enjoy the rest of your sunny, windy, cold day.